Welcome back, everybody, for another deep dive. This time we're going to be um, untangling audio cables.
Oh, yeah.
You know, those cords that seem so simple, but can cause like huge debates among audiophiles?
Right.
Yeah.
Yeah. It's amazing how much science and engineering goes into these
I
things.
know. And we have some pretty fascinating sources for today's deep dive.
Oh, yeah.
Yeah, we've got excerpts from an online forum about Belden's Iconoclast cables.
Okay.
And we also have a presentation by the guy who designed them, Galen Gaeris.
Cool.
So by the end of this deep dive, you'll understand how those cables are engineered and maybe even be able to decipher some of that audiophile jargon.
Yeah, you might even look at your own cables a little differently.
Exactly. So first up, who is this Galen Gaeris and why should we care what he has to say about cables?
Okay, so Gary's is an engineer at Belden, and they're known for making, professional grade cables.
Okay.
Not really like the high-end audiophile stuff.
So he's coming at it from a completely different angle.
Yeah, exactly. He's got this data-driven approach to audio cable design and focuses a lot on measurable performance.
Hmm.
And that raised some eyebrows, in the audiophile world where people are usually all about the subjective listening.
Yeah, I can see that.
He even got some pushback at first.
So he's like the outsider shaking things up.
You could say that. Gaeris wanted to make these cables that actually delivered measurable improvements.
And what are these cables called?
It's the Iconoclast series, and there's speaker cables and interconnects.
Cool.
Yeah.
So at the core of his design is this idea of coherence. What does that even mean when we're talking about cables?
So Gaeris says coherence is how well a cable handles different frequencies logically and consistently. You see, audio cables, they often have trouble staying consistent across the entire frequency range.
Yeah.
And that's what can cause audible differences in the sound.
So coherence is kind of like the conductor leading an orchestra, making sure every frequency plays its part at the right time.
That's a great way to put it.
What is it that throws these sonic instruments out of tune then?
That's where you've got the infamous trio: resistance, inductance, and capacitance.
Okay.
We can think of them as RL and C.
Okay. I'm getting flashbacks to physics class here.
Okay.
Can you break down these electrical properties for us?
Sure. So think of them as three characters on this electrical signal's journey.
Okay.
Resistance is trying to slow it down. Inductance resists any change in speed, especially for those high frequencies. And then capacitance is storing energy, which affects the slower, low frequencies.
It sounds like Grace is trying to find the sweet spot between those three.
Exactly. You can't really minimize one without messing with the others.
Yeah.
That's where the engineering smarts come in.
Now, I know we've got some serious audiophiles listening in. They've probably heard all this before.
Okay.
But let's dig a little deeper.
Sure.
The online forum was talking about skin effect and proximity effect. What are those all about?
Okay, so the skin effect is basically how high frequencies prefer to travel on the outer skin of a wire. The deeper parts don't do much.
So the inside's like wasted space for the high notes.
In a way, yeah. And then there's the proximity effect, which is how the current in one wire affects the current in nearby wires. Think of it like traffic. If one lane gets jammed up, it affects the flow in the other lanes.
I see. So that's why some cables use a bunch of smaller wires instead of one thick one.
Exactly. Gaeris uses multiple smaller wires to get better current flow.
That's smart, like adding more lanes to the highway.
Right.
Now let's talk about insulation. The forum was going crazy about the insulation in the Iconoclast cables.
Right, the dielectric constant.
What is that exactly?
It's a way to measure how much electrical energy a material can store. Gaeris uses this material called fluorinated ethylene propylene, or FEP for short. It's got a low dielectric constant, which means he can put those wires close together without causing too much capacitance.
So the insulation is like a referee, making sure the electrical stuff plays nice and doesn't interfere.
That's a good way to think about it. Now, there's also this thing called velocity of propagation, or VP.
Veep Curie. Okay, I've heard audiophiles talk about that, but not really sure what it means.
So VEEP is how fast a signal travels through the cable.
Oh, yeah.
But here's the thing, signal velocity can actually change depending on the frequency.
Really?
Yeah, meaning different frequencies can actually get to the speaker at slightly different times.
Wow, I never thought about that.
It's like a marathon where some runners get slowed down. It can make the sound muddy at the finish line.
So Veep linearity is like making sure all the runners finish at the same time.
Precisely.
Yeah.
Gaeris designs his cables to reduce these time differences by tweaking the RL and C to get a more consistent VP.
That's amazing.
Yeah.
We've talked about the signal going through the cable, but it doesn't just stop there, right? It has to go to the amplifier in the speaker.
Right, a cable's impedance, which is how much it resists the flow of AC current, interacts with both the amp and speaker.
Okay.
Can get complicated. And amplifiers hate dealing with what's called reactive loads, which are loads with high inductance or capacitance.
Why is that? I thought the amp's job was just to pump out the signal no matter what's connected.
It's a bit more nuanced than that. Remember how capacitance and inductance can store energy?
Right?
Well, that stored energy can actually make the amplifier go wonky, causing distortion or even damage.
So it's like trying to shove a square peg in a round hole.
Kind of, yeah. Gary's found that many audio cables have impedance that isn't good, especially for low frequencies. And this can actually cause reflections.
Reflections, like echoes in the cable.
Pretty much. They happen when the signal hits a sudden change in impedance, like a mismatch between the cable and the speaker.
Okay.
Then they can travel back to the amp, creating interference and messing with the sound.
So it's like those annoying echoes you get on a bad phone call.
Exactly. And these reflections are worse for those low frequencies where the speakers tend to be more reactive.
So if high capacitance and inductance are causing problems, wouldn't the solution just be to design cables with like almost none?
It's tricky. Remember our three-way tug of war? If you try and make one really low, it usually means another one goes up.
Yeah.
And if you push them both super low, the cable might not even be able to transfer the signal properly.
It's all about finding that balance.
Exactly. You need to reduce those reactive properties while still making sure the cable can drive the signal.
Sounds like a tough challenge.
It is. And that's where Gaeris' approach comes in. He's all about velocity of propagation linearity to minimize those reflections and improve the sound overall.
Veep linearity again. Seems like the heart of his whole philosophy.
It's definitely key. He adjusts the resistance, inductance, and capacitance of the cables to make that Veep more linear.
Like paving a perfect road for the signal.
That's a good analogy. So are you wondering about the type of copper used in the cables?
Oh yeah, the forum was talking about that too.
Yeah.
Is there actually a difference between different kinds of copper?
Well, Gaeris says there are some subtle differences. Yeah. The grain structure, like how the copper crystals are arranged,
Okay.
that can affect the signal transmission. But his research shows that the cable design matters more.
So it's not just the ingredients, but how you use them.
Right. Especially with those smaller gauge wires where the current flow is more controlled.
Okay.
So Gaeris uses 3 types of copper in the Iconoclast cables. Standard TPC oxygen-free copper, which is OFE, and silver-plated TPC.
SPTPC.
Yeah.
Okay.
And he found that the silver plating actually improves things even at lower frequencies.
Really? That's interesting. I thought silver plating was just for the high frequencies.
It's one of those things that kind of goes against what people think. Now, while we're on the topic of going against the grain, what about bi-wiring?
Yes, bi-wiring. That's where you use separate cables for the high and low frequencies in a speaker. Does it actually make a difference?
Well, Antares and one of his beta testers, Brian Wilson, they think it does.
Wait, Brian Wilson? Like the Brian Wilson from the Beach Boys?
That's the one.
Wow.
Yeah, so he was messing around with bi-wiring the Iconoclast cables, and he found that using different types of cables for highs and lows sounded the best.
So like mixing the copper types? I always thought you were supposed to use the same cables for bi-wiring.
It seems counterintuitive,
Yeah.
right? But it actually makes sense when you think about how different frequencies interact with the cable.
Like how that silver plating affects the high frequencies.
Exactly. So you could use SPTPC for the highs, and then OFE or TPC for the lows.
So you're giving each frequency band its own specialized path.
Exactly.
Yeah.
Tailoring the cable to what it's carrying.
This is blowing my mind. I never thought about cables like this. It's like this whole dance between science and sound.
That's a great way to put it. And speaking of that dance, let's get back to how the cable works with the amplifier.
You mean the impedance thing and how amps don't like those reactive loads?
Right. Gaeris found that a lot of audio cables out there have really bad impedance characteristics, especially for lower frequencies.
Which causes those reflections we talked about.
Exactly, those echoes in the cable.
Right.
And they're worse for lower frequencies because the speakers tend to be more reactive at those frequencies.
So he's not just thinking about the cable itself, but how it interacts with everything else in the system.
That's right. He's looking at the whole picture. Now, I remember Gaeris also mentioned something about ultrasonic welding.
Yeah, what's so special about welding compared to soldering?
It's about consistency and getting it perfect every time. Ultrasonic welding makes a really strong connection between the wire and the connector, and you don't need all that messy flux.
Hmm.
Plus, there's no chance of human error like you could get with soldering.
So it's more controlled and it'll be the same every time.
Exactly. And he's even super picky about the connectors themselves. He designed those locking banana plugs and spades to make sure the connection is tight and there's low resistance.
Wow, he really is paying attention to every little detail. But does all this fancy engineering actually make the music sound better?
That's the big question, right? Well, Brian Wilson said he was blown away by the clarity and the soundstage.
What exactly did he say?
He said the soundstage was jaw-droppingly wide and deep with like pinpoint accuracy for the instruments.
That sounds pretty amazing. Like these cables opened up a whole new dimension in his listening.
It's like they did. And it makes sense when you think about Gaeris' focus on Veep linearity.
Right, because that makes the soundstage more precise and defined.
Exactly. It's not just about how strong the signal is, but making sure it reaches the speaker at the right time.
Like those high-speed cameras that capture every single detail.
Perfect analogy. And then you've got Wilson's experience with bi-wiring. Using those different copper types, it adds another layer to the story.
Yeah, it's like he was creating a team of specialists, each cable doing what it does best.
Exactly. This whole deep dive has been eye-opening. I never realized there was so much to audio cables.
Me neither. It's not just plugging stuff in, it's a whole science.
It's all about those electrical properties and how they affect the sound we hear.
From coherence and Veep linearity to RL&C, we've learned so much today. It seems like Gaeris' approach is really changing things.
It really is. He's not afraid to challenge the way things have always been done.
Okay, so now that we're wrapping up, what are the key takeaways for all of us listening? Should we all go buy Iconoclast cables?
Not necessarily. It's not about just buying the most expensive cables or following the hype.
Right.
Gaeris wants people to really think about what goes into an audio cable.
So like looking beyond the marketing and stuff.
Exactly.
Yeah.
Think about why they designed it that way. The materials, they used all those engineering decisions. Look for evidence, not just people saying it sounds magical.
So basically, be an informed consumer.
Yeah. Know what you're buying and why.
Okay.
And remember, the best cable for you depends on what gear you have and what kind of sound you like.
Yeah. There's no one right answer for everybody.
Right.
This whole deep dive has been amazing. I'm seeing audio cables in a whole new way.
Oh, yeah.
Yeah. It's not just plugging stuff in anymore. It's like whole science.
It really is.
I never realized how much engineering goes into these things.
It's all about those electrical properties we talked about and how they affect what you hear.
From coherence and Veep linearity to resistance, inductance, and capacitance, it's fascinating stuff.
Yeah.
And Gaeris is really proving that a data-driven approach can make a huge difference.
He's shaking things up in the audiophile world.
Definitely. So the next time we're looking at audio cables, what should we keep in mind?
Remember what Gaeris said? Think critically, look at how the cable is designed, and don't be fooled by the marketing.
Great advice. Everyone's got their own opinions about audio, but ultimately it's about what sounds best to you.
Exactly.
This has been a fantastic deep dive into the world of audio cables.
My pleasure.
Thanks for joining us, and until next time, keep those ears open and happy listening, everybody.